Get that loaded here. So there's some powers of 10 that it looks like you need to know, and some rules of exponents that you need to know. So let me just give you a few kind of starter questions to see where you're at here. What is 10 to the 8th over 10 to the 5th? Can you tell me that?
10 over, or 10 to the 3rd.
10 to the 3rd power. Now, this is a 1 with how many zeros after it?
4. 3 only.
3. Yeah. So think.
Okay, because wouldn't you add 3 to the end? 3 zeros, because
Well, I mean, we're going to look at the series. So 10 is
Oh,
really 10
wait.
times 10 times 10.
Okay, yeah, that makes sense.
So that's why I'm just checking, because it's a quick thing. So it's what's kind of, I think, a little odd is like a million is 10 to the 6th. It's a 1 followed by 6 zeros. A billion is 10 to the 9th. And then so on, right?
Yeah.
So it's a 1. So it's always a 1 followed by the number of zeros there. Do you know why we separate with commas after 3?
So it doesn't get mixed up.
Readability, mainly. Yeah. All right. This is somewhat related to prefixes that you might see in other classes. That's not spelled right. Prefixes. Have you heard of like a processing power like a mega? You heard that before?
I mean, I've heard like megabytes
Right.
and stuff.
And then there's giga.
Yeah.
Okay. And these are all multiple powers of, these are powers of like we're doing here. It's just easier to sort of say mega hertz or gigahertz than to say, 10 to the 6th hertz in terms of its speed. And then it goes the other direction as well. So if you take a class in chemistry or physics, you'll see going the other way. You've probably seen millisecond,
yeah,
micro, there's pico, and so on. Okay, so let's get to some more problems that you care about so we can get some learning on today. Let's do some more problems here. What about 10 to the 8th times 10 to the minus 9? What does this become?
10 to the minus 1.
Okay. And how could I write this as a fraction?
1 over 10? No.
Good. Yep. Good.
Oh, okay.
Good. Trust yourself. Any idea what this is as a decimal?
0.1.
0.1. What is 10 to the minus 3 as a decimal?
0.001 or 001 or 0001. Just 00.
So it's kind of the go in the other direction here. It's 1 less 0 than this number here. So let's
Okay.
fill in. So 10 to the minus 2 is 0.01.
Okay.
See, there's only 1 0 before the decimal.
Yeah.
10 to the minus 4 is 0.0001. These are things that you do want to remember. Like that.
Got it.
Okay.
Mm-hmm.
All right. So let's say it's 10 to the 27th over 10 to the minus 18. Can you tell me what this becomes? 10 to what power?
Oh, 10 to the, hold on, 2, okay, 10 to the 9th?
So the rule is,
or 10 to the negative 9.
The rule is when the bases are the same, bases being the 10,
yeah,
and
you
you're
subtract.
dividing, you subtract. So you have to actually write n minus m. Doesn't matter what m is. M could be positive or negative. You still write n minus.
Oh, okay.
27 minus a minus 18.
That 9 or
There's two negatives.
So does that make it positive?
Yes. Yes.
Okay. So that's gonna be 35. 45.
45. Is it clear why it's 45?
Yeah, I just messed up.
At 8. Okay. So it's small things, right? But really can make a huge difference here. So let's try another one here. Let's say it's 10 to the 4th over 10 to the minus 7. What does this become?
4 minus 7. Okay, 4 minus 7. 4 plus 7 equals 11. 10 to the 11.
Okay, so this is a 1 followed by how many zeros?
11.
11. Yeah, very good. All right, let's try another one here. 10 to the 1.8 over 10 to the 6.8. What does this become?
Can you get a negative?
Sure.
Okay. So -5.
Yes.
10 to -5.
Okay, now tell me how many zeros are there to the right of this before the 1?
4.
Very good. Okay. Do you have any idea about what the mass of the Earth is?
No. Volume?
Mass. So the mass of the Earth is 5.97219 times 10 to the 24th kilograms. Okay, so this is a fairly large number. Do you have any idea how many pounds are in a kilogram?
No, I have no
There are
idea.
2.2 pounds in 1 kilogram. Okay. All right. Now you might be wondering, why am I asking this? What is 5.97219 times 10 to the 24th plus 100?
Oh, is that just 110 to the 20? 5.97219 times 110 to the 24th?
Nope. Think about, so one of the problems we have here is
Oh wait, no, 10 to the 25th.
this is sort of a deceptive question. Let me pose it differently. Do you know how many seconds are in a day?
No.
How would we figure that out? How many seconds are in a minute?
60.
Okay. And how many minutes are in an hour?
60.
Okay. And how many hours are in a day?
24.
So this ends up being 86,400. Okay.
Okay.
What is and let's go out a little bit further here. Let's do a full year, because that'll better illustrate the point. So that's 1 day. How many days are in a year?
365.
Okay. All right. So this is 315, 3, 6, 1, 2, 3. So let me say it correctly. It's 3,131,536,000 seconds in a year. Okay. So if I have the ability to add 1 more second to the year, is that meaningful?
Not really.
Not really, because and you might have heard of leap years as one example. So the idea is that like we're kind of off by a little bit, but it's so insignificant that it doesn't matter. Okay. And that's what I was trying to show you back here. The mass of the Earth is so large that like 100 kilograms is nothing compared to that. Like it doesn't even factor in. Okay. So that's just sort of an idea here to think about. Kind of the same thing with this time. It's like, well, let's say I could grant you 1 more second in a year. Okay.
So the equation would just stay the same for the plus 100 one?
Yeah, it's this original value.
Okay.
Because this one is so insignificant relative to the other one. All right, now let's actually do some problems like you wanted to do here. Let's say I wanted you to do 3.5 times 10 to the 30th times 1.5 times 10 to the minus 21. This is something you sent over in the notes. Do you have any idea how to do a problem like this one?
Would you just use commutative property and switch 10 and 21 and 1.5?
Exactly. The order doesn't matter. So you're going to multiply 3.5 times 1.5, 10 to the 30 times 10 to the minus 21.
Okay.
So go ahead and work that out, please.
So that's, what is that? So that's gonna be 6. No. So 5.25 times
Good. Times.
10 to the 54. No, 10 to the 51st.
So when the bases are the same, you add the exponents.
Yeah, to the, oh wait, hold on. 10 to the 9th.
10 to the 9th. Good. Okay, let's have you try one more of these on your own here. Go ahead and now work that one out for me, please.
Okay. Oh wait. Oh, you just need to add the zeros. Okay. So 1100 times, or hold on. Wait, no, we just did this. We need to switch them.
Yes.
So 2.75 times 10 to the 12th.
Very good. Okay, so the only thing that could maybe throw us off here, and we need to talk a little bit about like what is scientific notation. There's a base. I'm sorry, that's not the right word. Let me just check something real quick so I can use the right words. Okay, there is a coefficient. Make sure I get the right words here. There's a coefficient times 10, which is the base. Okay, this is always the base. And then there's an exponent. The coefficient has to be between 1 and 10, but it can be 1. It cannot be 10.
Okay. Yeah, that makes sense. Oh, I've heard this.
Yeah. And this is going to matter here in the next problem. So we're going to do some really simple. 4 times 10 to the minus 30 times 5 times 10 to the 50. Okay, so notice this becomes 20 times 10 to the 20. Is that okay?
Yeah.
So we have a problem though with this right here. The problem is it's bigger than 10. And we haven't talked about this at all, but do you know how to convert 20 into scientific notation? Do you know how to move the decimal or not?
I probably do, but I'm spacing.
Okay, that's fine. We move the decimal until the new number, which is now 2, is between 1 and 10. Okay.
Okay.
And for every one we move it, the exponent here
Gets larger.
could get larger or smaller depending on the direction we're moving it. So like what I didn't see in your notes.
Oh, it's smaller here.
Yeah, so the idea is that 20 is equal to 2 times 10 to the power of 1.
Okay.
So then what you would do is bring this one down, it would be 2 times 10 to the power of 21.
Okay. And that's just a lot of zeros.
Yes, which we obviously don't want to write.
Yeah.
All right, so let's try another one here. So this it's only an issue when when you multiply the numbers and it becomes bigger than 10. All right, so let's look at another one here. Let's say it's 8 times 10 squared, 2 times 10 to the 8th. So you're going to multiply these two numbers together.
Oh, 16 times 16 times 10 to the 10th.
Good. Now the problem with the coefficient is that it's too large.
So
Okay.
you move it to decimal.
Yeah, so you have to rewrite 16 as you're really moving it left. So it's 1.6 times 10 to the 1. That goes right here in front. And then you can combine these two.
Which is times 10 to the 11th.
Yes. So your final answer is 1.6 times 10 to the 11th. All right, so let me have you try one on your own here. Let's go with 7 times 10 to the minus 3, 8 times 10 to the 5th. Give me your final answer in scientific notation.
Okay. 56 and then 10 to the 2. 56 times 10 to the 2, but you can't do that. So 5.6 times 10 to the 10 to the 5th, or 10 to the 2, 10 to the 2nd, which is 5.6 times 10 to the 3rd.
Very good. Very good. Any questions on that before we
No.
do something else? Okay. So the next type of problem you'll see is a division problem. Like you'll see something like 4 times 10 to the 8th over 2 times 10 to the 7th. Let me make this different. Let me make that 18. And you really want to look at this in pieces. You really want to look at it as this piece and this piece. Look at the coefficients over the coefficients and the base to exponent over base to exponent. What does the 4 divided by 2 become?
2.
And that's fine. How about the one on the right? What's the
10 to the 11th.
good? Is the coefficient between 1 and 10?
Yes.
So you're done. Like this is good enough. Okay, but it doesn't always work out this way. So let's do the flip of this problem. 2 times 10 to the, what did I say here? 7th over 4 times 10 to the 18th. Okay. You still do it in this column approach. You still look at it as, okay, I got to take 2 divided by 4 and then this divided by this. So it becomes 0.5 times 10 to the minus 11 power. Do you see that?
Yes.
Okay, and the problem is that 0.5 is not between 1 and 10. So you have to write 0.5. This time you're moving the decimal to the right. So this becomes 5 times 10 to the minus 1.
Yeah, to the minus 1.
Minus
Okay.
1. So depending on which way you're moving it, it affects this exponent. And I think it's better if you figure out the rule through trial and error, or you'll see it tomorrow. But what I don't want you to do is get caught up in trying to remember, negatives go one way, positives go another. So that changes our answer. Okay, so this becomes 5 times 10 to the minus 1 times 10 to the minus 11. Notice that we now have to combine these again, 5 times 10 to the minus 12.
Okay. That makes sense.
Yeah. Okay, let's have you So if you try one here, let's go 3 times 10 to the minus 15 over 9. That's not a good one. Over 6 times 10 to the minus 20.
So 0.5 divided by, or 0.5 times, what do you call it? Negative 35. So 0.5 times 10 to the negative 35.
right.
But you can't do that, so
So what do you have to make? What's the change you have to make here?
you have to move it to the right, so it's 5 times 10 to the negative 1 times 10 to the negative 35, which
Okay.
then becomes 5 times 10 to the 36 or negative 36.
Good. Very good. All right. Yeah, really good. Trying to find another one here. All right, here's one for you to try. I'm going to change the exponent on one of these just to avoid a kind of a odd case here. So let's go -3 there on that one.
Okay. So 7.8 divided by 1.2 divide. Oh wait. 6. No.
Yes, it is 6.
6. Okay.
Sorry, but negative.
Times. Okay. Oh, times 10 to the 1.
This is a -3. So -3. What's the rule when you're subtracting?
When you're subtracting, a negative minus a positive is a positive.
Well, it's, I'm sorry, just to be clear, it's -3 -4.
Oh, okay. So negative 7 or 10 to the negative 7.
Good. All right. Yeah, let's go 6 times 10 to the -2 over 1.5 times 10 to the -5.
Okay. What do you call it? 4. Wait, 15, 30, 45. Yeah, 4. 4 minus or 4 times 10 to the negative 7.
You're subtracting, it's minus a -5.
Oh, so negative or times 10 to the 3rd.
Yes. Okay, so it's the little stuff that's tripping you up here. Just be careful on that. We are out of time here for today.
Mm.
But